Welcome to Astronomy Daily, your go-to podcast for all the latest news in the world of space and astronomy. I'm Anna, your host for today. We've got some exciting stories lined up for you, from NASA's Artemis 3 mission to the latest updates on the BepiColombo spacecraft and more. First, we'll dive into the latest maneuver by the BepiColombo mission as it prepares for its fourth flyby of Mercury. We'll also explore China's impressive 12th successful sea-based satellite launch, a significant milestone in space exploration. Later, we'll talk about how the Artemis 3 mission will leverage cutting-edge 4G technology designed by Nokia to revolutionize lunar communication. Finally, we'll unravel the mystery behind the enigmatic lunar swirls, shedding light on new scientific findings about these fascinating features on the moon's surface. So stay tuned for some incredible space news and insights. First up today, the BepiColombo mission, a joint effort by the European Space Agency, ESA, and the Japan Aerospace Exploration Agency, JAXA, is gearing up for its fourth Mercury flyby. This is not just another flyby, but a pivotal moment in the mission's journey. Scheduled for 2348 CEST, 2148 UTC on September 4th, BepiColombo will pass just 165 kilometers above Mercury's surface, getting closer than ever before. Why is this flyby so crucial? Well, it serves a dual purpose. First, it will help adjust the spacecraft's speed and trajectory, essential for eventually settling into orbit around Mercury. Second, it offers a valuable opportunity for scientists to gather preliminary data and fine-tune the operations of the onboard instruments before the main mission begins. Initially launched in October 2018, BepiColombo utilizes a series of 9 planetary flybys to aid its journey, 1 around Earth, 2 around Venus, and 6 around Mercury. The mission's complexity stems from Mercury's close proximity to the Sun, which demands intricate maneuvers to counter the Sun's powerful gravitational pull and the spacecraft's own high velocity. Interestingly, the upcoming flyby wasn't solely routine. Engineers had to overcome a challenge that emerged back in April 2024 when BepiColombo's Mercury Transfer Module, MTM, encountered an issue with its electric thrusters. These thrusters, essential for the spacecraft's journey, have been operating below the required thrust due to unexpected electric currents affecting the power distribution from the solar arrays. After months of grueling investigations, a workaround was devised. ESA's flight dynamics team created a new trajectory, ensuring the spacecraft stays on mission despite reduced thrust. This shows the resilience and ingenuity of the mission team, emphasizing that space exploration is as much about overcoming unexpected roadblocks as it is about discovery. The fourth flyby, set to occur soon, is expected to bring the spacecraft within just 165 kilometers of Mercury's surface, about 35 kilometers closer than originally planned. This closer approach will further reduce the propulsion needed for the next 2 Mercury flybys in December 2024 and January 2025, which are crucial for aligning BepiColombo's orbit with Mercury. What's exciting is that although the MTM's primary thrusters are underperforming, the mission's scientific objectives remain unaffected. 10 of the 16 scientific instruments on board will be operational during this flyby. These instruments will collect data on magnetic fields, plasma, and particles, offering a preview of the detailed science to come once BepiColombo settles into orbit around Mercury. Johannes Benkoff, BepiColombo's project scientist, couldn't contain his excitement. He pointed out that this flyby allows us to explore parts of Mercury's environment that wouldn't be accessible once the spacecraft is in orbit. This is a chance to gather unique data and ensure a smooth transition when the main mission begins. Moreover, BepiColombo's trio of monitoring cameras, MCAMs, will capture images of Mercury. While these cameras were designed to monitor the spacecraft's equipment, they also provide black and white snapshots of the planet. As the spacecraft zooms past Mercury, MCAM-2 and MCAM-3 will start capturing well-lit images 2 minutes after the closest approach, giving us unprecedented views of Mercury's terrain. There's an extra bit of excitement surrounding this flyby as it marks the first time BepiColombo will pass over Mercury's poles. This maneuver is essential for adjusting the spacecraft's trajectory to match Mercury's inclined orbit relative to Earth. Scientists are particularly eager to get a glimpse of Mercury's south pole through the captured images. All of these thrilling developments make BepiColombo's fourth flyby a cornerstone in its journey. With new data, images, and a fine-tuned trajectory, the mission is not just on track, but poised to deepen our understanding of Mercury and its place in our solar system. Expect the first images to be released on September 5th, and the initial scientific results to follow on September 13th. Stay tuned as we bring you more updates on this incredible mission, pushing the boundaries of what we know about our closest planetary neighbor. Next up in today's story list, Galactic Energy, a private rocket manufacturer based in Beijing, has achieved its third sea-based launch of the Series 1 carrier rocket, marking China's 12th successful sea-based satellite launch overall. This is a significant milestone for Galactic Energy, cementing its position as a leading private entity in the Chinese space industry. On Thursday afternoon, the Series 1 rocket blasted off from a mobile launch platform, which was essentially a modified deck barge positioned in the Yellow Sea off the eastern province of Shandong. The launch was a success, and the rocket deployed 6 satellites into a sun-synchronous orbit approximately 535 kilometers above the Earth. The newly deployed satellites come from multiple operators and serve various functions. They are set to collect crucial meteorological data, demonstrate advanced optical remote sensing technologies, and gather hyperspectral remote sensing data. These capabilities are expected to provide valuable information for both scientific research and practical applications, such as weather forecasting and environmental monitoring. So far, Galactic Energy has conducted 15 orbital launches with the Series 1 model, outpacing other private competitors in China. These missions have successfully placed a total of 54 commercial satellites into orbit, showcasing the reliability and effectiveness of their technology. The Series 1 rocket itself stands about 20 meters tall, with a diameter of 1.4 meters, and it primarily uses solid propellant. With a liftoff weight of 33 metric tons, the rocket is capable of sending a 300-kilogram satellite, or several satellites with a combined weight of 300 kilograms, into a 500-kilometer sun-synchronous orbit. Alternatively, it can deliver payloads of up to 350 kilograms into a low Earth orbit at an altitude of 200 kilometers. This successful launch not only highlights the capabilities of Galactic Energy, but also underscores China's growing prowess in space exploration and satellite deployment. The use of sea-based launches offers unique advantages, including increased launch flexibility and reduced risk to populated areas. Now let's get an Artemis update. NASA's upcoming Artemis 3 mission is set to break new ground, not just by landing astronauts on the moon again, but by equipping them with cutting-edge communications technology. The spacesuits these astronauts will wear won't just be your regular space attire. They'll come with 4G connectivity, designed by none other than Nokia. Imagine this: lunar explorers broadcasting high-definition video or transmitting large volumes of scientific data back to Earth in real time. It's a huge leap forward from the traditional UHF radio communications that past missions relied on. Nokia's innovation essentially miniaturizes a mobile network tower into a box that can fit onto a lunar lander. This compressed base station will allow the astronauts to stay connected up to 2 kilometers away from the lander, a considerable range when you think about it. On Earth, a network of base station towers dotted landscapes to keep us connected. But on the moon, we only need this compact system, demonstrating how scalable and adaptable our technology has become. Now, the Axiom spacesuits, crafted by Axiom Space, won't have a touchscreen interface like the smartphones we're all accustomed to. Instead, the suits will integrate components of a smartphone, customized for the space environment. What they'll gain from this integration is remarkable, including the ability to stream high-definition video or send substantial scientific data back to the base station, which will then relay it to Earth. Traditionally, UHF radio has been the go-to technology for astronauts during their lunar missions. While UHF has served well, it pales in comparison to the higher bandwidth and faster speeds offered by 4G. Nokia has been working on this technology for space applications since receiving a $14.1 million NASA grant back in 2020. The company envisions a future where 4G connectivity will benefit not just Artemis 3 astronauts, but potentially all future lunar missions. In fact, the first test of this lunar 4G network will occur later this year with Intuitive Machines' IM-2 mission. This mission will carry the base station, while 2 other payloads, the MAP rover and the Micronova drone, will have 4G receivers. Beyond the Artemis 3 mission, Nokia sees potential applications for this technology in various lunar devices. Think of a lunar terrain vehicle equipped with 4G connectivity or even smaller science experiments and sensors linking through this network. Throughout 2024 and into 2025, the 4G-equipped suits will go through rigorous testing, everything from vacuum chambers to simulations in the indoor pool at NASA's Johnson Space Center. These tests aim to ensure that both the suits and their components can withstand the extreme conditions they'll face during life on the moon. This technological leap doesn't just make communication easier, It opens the door for more advanced scientific exploration and data collection. It's an exciting time for space exploration as we blend the advancements made in consumer technology with the rigors of space travel. The Artemis 3 mission, with its 4G connectivity, is certainly one to watch as we prepare for humanity's next giant leap on the lunar surface. Let's explore a truly fascinating topic: the mysterious light-colored swirls on the moon's surface. Visible through even the most basic backyard telescopes, these lunar swirls have long puzzled scientists. Some say these swirls resemble the brushstrokes in an abstract painting, but they are far from mere artistic flourishes. NASA's images show that these intricate patterns can extend for hundreds of miles. So what's behind these captivating formations? Recent studies suggest that lunar swirls are the result of magnetized rocks. These rocks create a magnetic field strong enough to deflect solar wind particles, which bombard the moon continuously. While nearby areas darken over time due to chemical reactions caused by these solar winds, the swirls maintain their lighter appearance because they are protected by their magnetic fields. This brings us to a crucial question. How did the rocks in these swirls become magnetized? After all, the moon no longer has a global magnetic field. Recent modeling and spacecraft data have started to unravel this mystery. One popular theory is that these magnetic anomalies were caused by impacts or possibly by subterranean lava, with high titanium content cooling down in the presence of an ancient magnetic field. Assistant Professor Michael J. Kraczynski from Washington University believes that localized magma could be the real culprit. His recent experiments, co-designed with PhD graduate Yuanyuan Liang, tested whether lunar light conditions could magnetize materials like ilmenite, a mineral abundant on the moon. They concluded that high surface area to volume ratio in ilmenite grains could indeed create the necessary magnetic fields. These theories have significant implications. Understanding the origin of lunar swirls could help scientists piece together the historical magnetic environment of the moon, revealing more about its geological history and even the broader surface effects experienced by other planets and moons. Looking ahead, NASA intends to send a rover to one of the most famous lunar swirls, Reiner Gamma, in 2025 as part of the Lunar Vertex mission. This mission aims to gather more data and possibly provide direct evidence of the processes behind these enigmatic patterns. Thus, while the mystery of lunar swirls has yet to be completely solved, ongoing research and upcoming missions are set to offer invaluable insights. For now, the study of these swirls continues to excite the scientific community, bridging the gap between remote observations and hands-on lunar exploration. And that's all for today's episode of Astronomy Daily. Thanks for tuning in. If you enjoyed today's episode, please visit our website at astronomydaily.io, where you can sign up for our free daily newsletter, catch up on the latest space and astronomy news with our constantly updating newsfeed, and listen to all our back episodes. You can also find us on social media by searching for Astro Daily Pod on Facebook, X, YouTube, and TikTok. Have a great day and keep looking up.